what I'm going to talk about in this video is just difference between elements, molecules, mixtures, also about the different states they can come in. So for example, in solid, liquid, and gaseous state. And if we have mixtures, how we can separate those mixtures using separation techniques. So for example, how we can separate solids from solids and liquids from liquids. I'll start with definitions of elements, molecules, and mixtures. And I'll start with the element itself. So an element is what we call a pure substance. So what I mean by that is if we have, for example, gold elements or gold atoms. So each of these here is a gold atom. Right, this is a gold atom. Each of them will have the exact same physical properties. They will have the same color, they will have the same shine, they will have the same weight as each other, right? And if we were to make them, try to make them smaller, so we go from the smallest unit, which is the atom, and we maybe make it into protons, which is one below, that means they would lose all of their properties. So a pure substance is a substance that we can't make any smaller without losing all of their unique properties. And an element, which is one version of an atom, so in this case we have 118 different elements, because if you look at our periodic table, we have 118 elements on there. And each of these elements would have their unique properties. And gold is just one of those 118. So gold elements would have their unique properties, as I just mentioned. Now the next one you need to know about is your molecule. And your molecule is a bit different to your element, because that's when we have two or more atoms joined together. Atoms joined together. That's your actual definition for a molecule. Now, what I mean joined together, it means it has bonds between it. So this would be a covalent bond. Molecules will always have covalent bonds. And if it's just in its pure substance state, if it's just by itself, it won't have these bonds. But if it's a molecule, it will always have bonds between atoms. Now, what I'm talking about here, this one has two different types of atoms. So it's got your oxygen atom and your carbon dioxide atom. So that's oxygen and that's carbon. It's not a carbon dioxide atom, it's a carbon atom. But that's CO2, right? So this molecule is called CO2. And it's a molecule that has two different types of atoms, but we can also have a molecule that has just one type of atom, as long as there's two of that atom joined together. So what I mean by that, if each of these is oxygen, then what I'm drawing right now is called O2, and that's oxygen gas, so that's O2, and that's also going to be a molecule because it is two atoms joined together. So it's two or more atoms joined together. They can be different, like with carbon dioxide, but they can also be the same, like with oxygen. Right? That's a molecule. Now, what is a mixture? And you can use, for example, Coke or Coke Zero as a mixture. Because if you look at Coke, what Coke actually is made up mostly of is water. So each of these here, the ones I'm circling now, is a water molecule. So about Coke Zero would have about 98% water. Normal Coke would be about 90% water. So most of Coke is water. You also tend to find carbon dioxide because that's the bubbly, the fizzy part is carbon dioxide. So this here is CO2. That's your fizzy part of Coke. And then you also have something that makes it sweet. So for example, in Coke Zero, that would be a sweetener. Right, so that makes it sweet. And in normal Coke, it would be sucrose or a different type of sugar. And that would make it sweet. So if we're looking at Coke, a bottle of Coke, it wouldn't just have water or carbon dioxide or a sweetener of some sort. It would have all of them joined in one mix together, right? So that's what a mixture is. Just more than one type of molecule mixed together makes a mixture. And what's important is they're mixed together, they're not bonded together. So you don't have a really strong bond between all of these molecules or elements or whatever might be in that mixture, but you just have these tiny weak bonds that make it all come together. But that's the mixture. So if we're trying to separate a mixture, if we're trying to separate, for example, water from sugar, sucrose, we need some technique to do that, and we'll talk about that very soon, and that's your separation techniques. They deal with mixtures. What we also need to know is we need to know what is solid, liquid, and gases. So solid, liquid, and gases, these are your states of matter. So each of those molecules or elements can come in these states. A solid is basically just your ice in this case, because we're talking about water. So solids can be a lot of things, but right now we're just talking about water. Each of these examples is water. And water can come in a solid state, which is ice. Water can also come in a liquid state, which we call just liquid water. And water can also come in its gaseous state, which we call water vapor. So that's water vapor. Now what you need to know is you need to know basically what it would look like on the small scale. So each of these atoms in the solid, they don't move much, they don't have much heat energy, but they have a tiny bit. So what you'll find is you find that each of these water molecules in the ice can move a tiny bit, and we call those vibrations. So in a solid, we basically just have vibrations happening. That's tiny bits of movement, but there's not much movement. But if we go from a solid to liquid, we call that melting. And the opposite, going from liquid to solid, we would call that freezing. But if we actually go from a solid to liquid, what that actually means is we're basically increasing heat energy. That means each of these water molecules has more heat energy than they did beforehand. And that means that now they're moving a bit faster. So beforehand they were just vibrating. Now they're sliding past each other. So they're sliding. So vibration for a solid and sliding for a liquid. And then if we go from a liquid to a gas, we call that evaporation. Again, same thing, we increase our heat energy even more. So beforehand it was sliding. Now we've increased our heat energy even more when we go from a liquid to a gas. And now what you're going to find is those actual atoms here can move freely. They're floating around, fizzing around in the air by themselves, not being close to each other or not having to be close to each other. They're moving quite freely. So this is moving freely in the gas form. And all of your molecules or elements, most of them can be in all these different states, right? But it's just to do with how much energy they have. So if we remove all the energy from water, we make a ice solid. If we melt it again, we make it into liquid. If we add even more energy, heat energy, we make it into gas. And one example where we find each of these three states of water is close to South North Pole. This would be your ice cap right here. That would be just solid water, which is ice. Here we've got our ocean. That would be liquid water, which would be just your normal water. And then on top we've got clouds, and clouds are actually mostly water vapor, so that's water in its gaseous form. So in this picture we have three states, all three states of matter that water comes in: solid ice, liquid water, and gaseous vapor. What I'm going to talk about now is separation techniques. That's techniques we can use to separate different mixtures. So for example, if we have solids from different sizes, so if we try and separate a solid from a solid of different sizes, for example rocks from sand, we know that rocks are much bigger than sand, so it's much easier to separate rocks from sand. All we have to do is we have to use a sieve, because that will have pores that have different sizes. So it means that these pores will allow sand to pass through and collect on the bottom, but the pores are too small to allow rocks to pass through. So rocks are going to be stuck and they'll be on top and sand will be on bottom. So now we've separated sand from rocks using the physical property of the size of each of those solids. Another example of how we can separate a solid, in this case from a liquid, and this is an insoluble solid. So that means insoluble means does not dissolve or can't dissolve. And now we're going to talk about how we have an insoluble solid and we try and separate that from a liquid. So what I mean by this is if we, for example, if each of these gray dots is supposed to be just made of more or less your mud or your sand. So we have sand water, that's a mixture, sand and water or mud and water. We know that if we keep that just standing for a while, what's going to happen is that mud is going to collect on the bottom. So the mud will just drop to the bottom over time, and we have mud on the bottom and we've got water on top. And now what we can do is we can do a technique called decanting. And if we do decanting, what that means is we slowly pour out the water. The water we slowly pour it out into a new beaker, and all of that sand or mud that's accumulated on the bottom, we make sure that we don't pour that out, right? We pour the water out carefully, and over time all the mud is going to be in one beaker, and all of the water is going to be in another beaker. That's what we call decanting. Now, I'm going to talk about how we can separate a soluble solid. So that's a solid that does dissolve in water. So a soluble that does dissolve in water. So how we can separate a soluble solid from a liquid. And we use a technique called evaporation plus crystallization. That's a really important one to know. Evaporation plus crystallization. Just two steps here. We've got salt water here, salt water. So this here is salt water. And remember, salt dissolves in water. That's why this is a soluble solid from a liquid technique. So salt, we want to separate the salt from the water, but salt has dissolved in water. So what we can do is we can actually evaporate the water. So that's why it's called evaporation crystallization. The first part is evaporation. So here we've got a Bunsen burner. The thing on the bottom is supposed to be a Bunsen burner. This one right here. We're heating up this water, and that's actually evaporating the water. And then what we're left up after less than 20 minutes, we're left with the water being all gone because that's been evaporated, and we're left with just these crystal salt particles. So this is your crystal salts. So we've crystallized salt, and that now where your solid is separated from your liquid, and we use evaporation crystallization to do so. Right, so that was that technique. And another technique you sometimes can see is the separation funnel. So the separation funnel, and we use that to separate a liquid from a liquid. Two liquids that have different densities, so they have to have different densities. And one example of this would be your oil and water. Oil always floats on top because oil has lower density than water, and water will have the higher density, it will be in the bottom. So if we mix like this, all we have to do, the separation funnel has a tap that we can open. Now we want to make sure that by the end oil and water is separate, right? So if we open that tap, we let the water flow through, and it's on the bottom because of the higher density. If we let the water flow through, and then once all the water is gone, we close that tap again, then we'll have separated all the water in one beaker, and the oil is still going to be in the separation funnel. So now we've separated oil from water using the separation funnel technique. Right? So that's how we can separate a liquid from a liquid that have different densities. Now if we have a liquid and two liquids that have different boiling points, we can use something called distillations. Distillation. Hopefully I spelled that right. So distillation is used when we're talking about different boiling points. So for example, ethanol has a boiling point of about 78 degrees Celsius, and water has a boiling point of about 100 degrees Celsius. So you can see that ethanol has a lower boiling point. So that means it's easier to make into gaseous form. So ethanol is easier to make in gaseous form, whereas water is harder to make into gaseous form. Now this solution right here, that's in this beaker or in this flask right here, is going to have a combination of ethanol and water. So there's going to be some ethanol in here and some water in there, mostly water. But we're trying to separate the ethanol from the water. So we have to use some technique, and this is going to be distillation. So what we're doing is we're applying heat, and that heat might be at a temperature of roughly, say, 80 degrees. So if we have a temperature of roughly 80 degrees, what we're going to evaporate mostly is ethanol, right? Because ethanol has a boiling point of 78 degrees. And we're going to evaporate some, but not much water, because it has a much higher boiling point. So mostly ethanol will evaporate, and then it will flow into this condenser. Basically, the condenser makes it go from a gas back into a liquid, and then we can collect it in a actual beaker at the end. So now, over a period of time, we have mostly ethanol in this flask or in this beaker, and what's remaining here is mostly water because the ethanol has evaporated and gone into this separate beaker. So this is a separation technique we can use to separate a liquid from a liquid that have different boiling